In this video, we'll be using CurveSuite to create a simple feather, which we will then be using to render out textures. To start out, I will select and delete our cube and our light source in this default Blender scene. I will delete them. I will reset the rotation and positioning of our starting camera. I will go to our asset browser. I will add in a plane object, which will be the stem of the feather, so to speak. We'll scale it down on the x-axis. And then offset it on the y-axis so that the origin point of the object is pretty much where the feather will be starting. We'll add in a curve object. Doesn't matter whether it's a Bezier or path. It's up to personal preference. I will offset it with the same logic in edit mode. I'll go back to our stem object. In edit mode, I will extrude it on the z-axis for it. I will hide our camera for now. I will call this the fluff. Still be the fluffy part of the feather. Underneath scatter suit, I will select curves for curves and then drag and drop it over to our curve object, the fluff. Underneath our modifier panel, I will select the stem object. It has already started to emit these subcurves, but they do not look ideal for a feather. For one, we want them to cover the sides. Here we have some coming out the bottom. And this side, there's a lot of empty spaces. This is because, well, the bottom part having curves and top part not having curves is because of the curve proximity cutoff parameter. If you go to edit mode and then move these parts up, you can see the exact opposite is happening, where we're getting curves on the top faces, but not on the bottom faces. And if we set this to 0, distance no longer plays a role, which then means these parts are getting curves as well. But with the feathers, we want there to be a bit of a gap between the point where these sub curves start and where the actual feather itself starts. So for now, I will keep it at 0. In our stem object, I will also hide our flow object for now. In edit mode, I will add in a bunch of edge loops along the length of it. And then I will add in 2 edge loops in this direction. I will scale them on the Z direction so that there's a very small gap here. I will create a new vertex group and assign this middle face loop to be this group. Now if we go back to our fluff, underneath the modifiers panel, we have these parameters that control the distribution and the density of these subcurves. For our density factor, it is set to 1, whereas we decrease it, there are less curves, and at 0, there are no more curves. If we hit this button here and type in the name of our vertex group, we can now see we are not getting any curves on the top or the bottom faces. Now this is not really a perfect feather when you look from the side, but with this setup we are planning on rendering it out anyway, so the current state doesn't really matter from any perspective other than the top perspective. I will go to edit mode on the stem object. I will add an edge loop at the center. I'll just make the tip of the feather a bit more pointy. So we already have a pretty decent starting point. So now in edit mode and in our fluff object, we can use curve editing tools to configure this setup. We can also increase our curve proximity cutoff. Let's say 0.5 for now, which will let us control where the curves actually start by adjusting the positioning of this control point. In Control T, we can control how much they flare out. And with Alt S, we can control the length of these subcurves. You can see as we reduce the resolution of our fluff curve object, the generated subcurves don't have as much of a smooth stepping between the radius and the tilt parameter we set for this control point, and the same parameters we set for this control point. We will most likely want this value to be as high as possible, unless you're going for a more stylized look. And with how curve objects work in Blender, particularly the Bezier objects, you can mess around with the positioning of these handle points to further adjust the influence each control point has on points in between them. This is a decent enough starting point, I think. So underneath curve manipulation, I will add in displaced curves, because I want there to be some natural displacement. We'll set all the displacement parameters to 0 and then work from there. Where normal is the normal of the curve, so it's not really something that will be useful for our purpose. And tangent is the direction along the actual curve, which can give it a bit of a natural look. What we're more interested in is the cross displacement. And as we change the fall-off exponent, nothing's really changing, because these generated subcurves are only made of 2 control points, and there is no displacement at the root. So only the tips are being pushed around, so they're still perfectly linear. So we can change the curve resolution parameter for our curves to fur curves directly. But this is a bit harder to work with, so I will just keep that at 0 and actually use resample curves and place it before our displaced curves. Here we have much more control over the generated subcurves resolution than we did with the curve resolution parameter of curves to fur curves. For example, we can set a specific control point count for each curve. And now I'll keep it at 8 or maybe 12. I'm going to try and add Blender's own clump here curves modifier to see how that will help. Because with this modifier, before it applies its effect, it also subdivides curves. And with our sample curve being before it and being set to 12, there will be a lot of control points. I'll showcase it by adding in curve to mesh at the end of the stack. And with wireframe mode on, you can see these subcurves are very dense. We have nearly 1.4 million triangles in the scene. So what I'll do is I'll duplicate our example curve and then have an exact copy before our curve to mesh. Without this, Blender will work very slowly. But with this, it is a lot more manageable. Now, because of our clump here curves and the way it works, we have our curves from the left side getting bundled up with curves from the right side and vice versa. So one way to prevent this is to just toy around with the curve distance parameter until they no longer overlap. But then we don't have as much control over how much they get clumped into singular clumps. So one way to prevent this is to just have another copy of our curve and modify these. Rather than having a single object, a single group from our stem object, we can have two groups. We can call one left and call the other one right. We'll go to wireframe mode and select our group. I'll deselect the left side, and on the right group I will remove. And then I'll do the same for the left, though I forgot to assign them first, so should probably do that first. Deselect the right side on the left group, or rather the right group, remove, because we have the left side selected still. And then deselect the left side, leave only the right side selected, and then remove them from our left group. Let's rename our existing fluff left fluff, and the new one right fluff. And underneath, we will need to change our density vector from group to left. And for the right one, we'll have to do the same, but type in right. Now we have two separate objects for these separate sides. And we can even make asymmetrical feathers, because the edits are independent from one another. But one way to fix that is, here I'll just rename the actual curve data block names. If we press this drop down button, we can change the actual curve data this right fluff object is using. And if we set it to be the same as the left one, any changes we make in edit mode will reflect to the other one. This is exactly the same as hitting Alt D when making the initial copy rather than pressing Shift D, but this is an alternate way if you use Shift D to create a duplicate that isn't linked, where you meant for it to be linked and then you did a bunch of work. You just don't necessarily have to lose the work you've done, as long as it was based around the changing the modifiers. Any changes you do make in edit mode will be lost, because this will be using the left data block. I'll try and remove the exact tip from both groups to see how that works out. I think this is a decent enough shape. Based on your personal preference, you can keep working. You can keep adjusting the curves themselves. You can make adjustments with the modifiers. You could even create more duplicates for more variations, which will also show in a bit. I will select our left fluff and right fluff, and then select our stem, and Ctrl P to parent them to the object. And then I'll offset them in the x-axis by 0.5. And then I'll select all of them. I will Shift D to make sure that I create a duplicate of everything I've selected, but the duplicates are not linked. I will offset on the x-axis by 1, and then do it one more time. Now with our camera, I will offset it in the x-axis by 1.5, and on the y-axis by 1.5. I will set it to orthographic mode. Stop on the z-axis. And let's say 1024 for resolution. Oh, 2K. Now with an orthographic scale of 1 and aligned with the z-axis, it will only capture this middle square of the grid. So we'll set the orthographic scale to be 3. And with this setup, we can render out 3 variations of the feathers in one go. So we can make adjustments to one without it being destructive to the other ones. As a final touch for further modification on these, I will showcase how to use the lattice modifier with them. I will set our 3D cursor to be the root of our stem. I will add a lattice object. I will move along the y-axis by 1.5 units, and then scale along the y-axis by 3. I will set our W resolution to be 1, because these do not need any depth for our purpose. And I will increase the other two resolution parameters. First, I will add a lattice modifier to our stem object, and then select our lattice. And I'll select our other two objects and then copy to selected. But with this current setup, if we go to edit mode and make changes, you will see that it is sort of pushing the generated fluff twice. This is because of how Blender evaluates objects when you select them as the parameter for a modifier. Here, our target geometry for the cursor for curves is the stem object, which has a lattice modifier. And then we have another lattice modifier at the end of our stack, so the cards are, or the fur curves are being generated from this stem with the lattice modifier, and then having the lattice modifier effect applied again. So it is being applied twice total. So if we mute the lattice modifier, you can see they actually line up without it. But one issue is, you can see, like, as we change the lattice object, the generated curves are actually being changed as well. They're not just being molded with it, it's actually affecting the generation, which isn't really something I want. So one thing you can do is, you can just have a linked duplicate of your stem object with the lattice modifier, and then just get rid of it in the original one. And now if we hide our stem and we enable the lattice modifier for this fluff, we can displace the generated fluff without actually affecting the generation or the displacement or any of the other effects. So it will only affect the final result, which will give us yet another layer of configurability. So you can create any adjustments or edits or variations you want. Like for example, you're happy with everything else about it, but you don't want the tip to be so forward or like so away from the rest of it. You can just push this part in, or you can make it curve around like this. You can reduce the fluffiness in certain parts, or make it more chaotic. It's entirely up to personal preference. Now as our final step, I will also showcase some parameters you can use in the shading, which will not be any different compared to how we did the tail, but I think they're still worth showing. And I will add in a new material, which I will call fluff. And for the stems, I will assign the existing default material and call it stem. With the fluff modifier, even though it is added to one of the fluff objects, as with the tail showcase, if you change the stem shader, it actually affects the stems, but the fluff shader doesn't affect the fluff, because we have to assign the material in our curve to mesh modifier. As far as the texture coordinate node, we will most likely be a bit more limited, because if we use the separate XYZ node and hide the curved stems, since it is using the bounding boxes of these objects, I will also hide the lattice so that it's easier to see. If on our viewport display, I will enable the box bounds display. You can see this part is being mapped to 0, and then these parts over here are being mapped to y or 1 in the x output of our separate xyz, which might make the texture coordinate node generated output less useful if you do use the lattice modifier to edit them. But depending on what your use case for them is, it might not matter. The y output will most likely still be equally useful because the roots will be 0 and the tip will be 1. And z is just the depth, which is always useful. And we can also use spline UV map. and the X helped is around the profile, which might not be very useful for this case, but Y is along each individual fluff strand's length. I will shade these feathers is mostly up to personal preference, but I think this is a decent enough stopping point to showcase what is possible. As one last step, I will go to our render properties panel, and under film, I will enable transparent so that our rendered image texture will actually have a transparent background, which will make it more usable. In the next step, we'll be using these feather textures to render out a wing, where the polygon count will be much lower than if we were to use feathers like this, but the end result will look almost just as good, especially from a distance, which will hopefully make it more useful for game engines.